a lot of the criticism for incrementality tests and geotests that there's often a large cost associated with it. It's not a $0 endeavor, especially like if you're a huge company and you've got a massive monthly ads budget. You want to figure out if those ads are incremental or not. You have to turn 50% of them off. 50% of $20 million is $10 million per month. Like that's a huge cost there. Obviously smaller for startups. But the thing with geotests is that it's not a true incrementality test, right? Like randomization is the core element of control groups and treatment groups. And then at geotests, we're handpicking the regions and not doing it like we would in a mass market incrementality test. Maybe chat about some of the limitations of incrementality tests and geotests. What are your thoughts there?
Sure. So there's this thing called fundamental problem with causal inference, right? So before we get into geotest, let me try to explain that particular problem. So for example, in an organization, say you have launched a new policy, right? Now you want to measure if your employees are happy about this, right? But there's only one reality. You have launched the policy, right? Now you are measuring this, right? You don't have the counterfactual of in another universe where you didn't launch this policy, right? So that counterfactual is never visible. In geotesting cases, we are creating a counterfactual. So we pick a few geographies and we are creating a counterfactual, which is a set of geographies, another set of geographies. And we're making an intervention in your treatment cluster. And the other set is what is used as counterfactual. So you're assuming that from the past, these two set of geographies were very similar in the way they were contributing your revenue or whatever outcome. So you're assuming your counterfactual or your control group will continue as is because you're not intervening there, right? But you're making some interventions in your treatment cluster. Now you could measure this difference. Now, most of the pushback that we get for geotesting is the primary concern is that it's costly, right? Because most of these tests has to run for a period of 3 to 5 weeks, right? So it's a slow process and it's a very rigorous process. It's a lot of overhead on the marketer because they've got a lot of other things to worry about. Now they need to spend 3 to 5 hours running a test, and it has to be, you have to babysit the test, right? You have to control for
Yeah.
a lot of things. So there's opportunity cost. Now, the other factor that you mentioned, you will have to scale up or hold out your investment on certain channels in certain geographies. And these geographies might be contributing a significant chunk of your revenue. But for those things, there are statistical solutions. So we could create a test where your opportunity cost is the lowest possible, right? We could pick the group of cities or states which perhaps only contribute to 5 to 10% of your revenue, and we could we could run a test in the shortest possible time, but making sure that we don't compromise on the statistical power of the test. So there are ways in which some of these things could be addressed. But having said that, it needs more commitment from the marketing team, right, to run these tests and to get these reads back to your optimization system. But having said that, this is a better way to measure as well. Right? Here you have got more control. This is a slower process, but you could adopt the learning with more confidence, right? Unlike other measurement system. So the framework that we have in mind is, so you've got a fast system of measurement. The fastest is being attribution perhaps, but it is less accurate and less actionable. Then you have models, right, that you could create on your historical data, which is something that you could create in a few days to a couple of weeks. Now, the problem with the models is you won't have high confidence on all the reads that you get. Right? So, for example, if you are having 10 input variables and you're trying to understand the impact of all of this, some of these input variables could be sparse. You could have certain data challenges around multicollinearity and things like that, which means you cannot interpret the reads on those variables with high degree of confidence. So that's when you should move to testing, right? So you should first have a process in place where you could generate intelligent hypotheses so that you are using up your bandwidth the right way, right? Running the right tests, the most important ones. And for everything else, you could have quasi-experiments, which is where your model sort of comes in.
And like the quasi-experiment stuff is where you're talking about like minimizing the opportunity cost of some of these tests. Because like the part that I've struggled with doing this in practice is that like it sounds really good to minimize the opportunity cost. Marketing team is kind of reassured a little bit, but when you dig into the minimal detectable effect of how long you need to run this to get the right sample size, then like the opportunity cost is still kind of growing, and you're looking at like, oh, how close are we to get like that sample size to me? Maybe chat about that a little bit, like the minimal detectable effect variable in this whole like incrementality testing. How do you think about that?
True. Yeah. So there are a couple of approaches, right? So primarily what we are trying to do is we are trying to infer causality, right? We are trying to do causal inference.
Mm-hmm.
And there are broadly two ways in which we could do this. One way is what we call quasi-experiment, or it's also popularly known as natural experiment, which means your historical data in itself would have enough variations in it for you to infer causality from it, right? So the first entry point to incrementality test or incrementality reads is to create models on your historical data and see if you can infer causality out of it. So this is where your MMM system comes in. Now, coming to your question on the incrementality test itself. Yes, it's very important to design the test in such a way that you get conclusive outcomes out of this, right? So let's take an example. So say there is a particular brand which is spending $1 million a month, and the brand gets $5 million out in revenue, right? So this is 5x. Your blended ROAS is 5x. Now, this particular brand wants to test a new channel, right? So the next month, they introduce a new channel. They spend just $50,000. So now your spend is $1,050,000. And they see a revenue of $6 million. Okay. So this is a test. I've just added a new variable. But this $50,000 is giving me 1 million of delta, which is a 20x ROAS. So the question is, was this a good test? Was that additional 1 million the result of some other seasonal factors, right? So this is an example of longitudinal study or time testing, right? So that 1 million is perhaps because it's December or it's whatever, it's your peak period, it's winter and you're selling winter clothes. So this $50,000 is not driving that. So you should design a test so that the investment should primarily make sense, that it should be able to drive an effect that is detectable, and also you should factor in all these seasonal things. So that's where geo-testing is important, because geo-testing is not this time-based testing. In geo-testing, you're taking December and you're picking two set of geographies that work very similarly on all the previous Decembers for which you have data, right? And then you are adding a new channel for, say, one of those geography cluster. Now, you could make a meaningful inference. So testing, as I said, is perhaps the best approach, but it's a very rigorous approach. Design of testing is what you should get absolutely right, because rest of the testing, which is to deploy the test, get the read back, and compute the lift, all of those are trivial in some ways. You could easily operationalize that. But if you get the design wrong, then you would end up having a test which is not conclusive. You have wrong reads out of it, and there are a bunch of different problems. Now, the opportunity cost minimization that I spoke about was that when you design the test, you could perhaps design the test which is of shorter duration. But having said that, you will have to invest more if you want to reduce the duration. But if you want to run a powerful test, that is mostly a slightly longer duration test, lower spend, but it would take more time to do. But you could complement or augment this entire testing process with the natural experiments. Right? That's where MMM sort of comes in. Right? If you have 10 factors for which you need to measure incrementality, you need not test all 10. The first responsibility is to generate the right hypothesis that warrants testing, and MMM is a very good hypothesis generator.